So everything big happened. Before everything big happened, always something happened, right? Every time, always like this. So here it's very happy to come here to give the speech about openEuler. The topic is openEuler bringing new opportunities to the diversified computing era. So I'm Wei Xiong. I'm the member of the technical committee of the openEuler community. Okay, so the first question is, when we talk about the openEuler, maybe somebody say, okay, is kind of another boring OS distribution? The answer is no. So let clarify what's the problem we try to resolve. Personally, I think there are three tough challenges for the OS industry. The first one is the fast development of chipset bring tough challenges for the OS development. I think the chipset has been very booming in recent 3 or 4 years. And in the future, we can forecast that there are more and more new type kind of chipset will appear. So the second one is the OS need a more aggressive innovation to bring things to be lighter and faster. So personally, I think nowadays the OS, especially for the Linux system, it become bigger and bigger and heavier and heavier. So our idea is how to reduce it and reduce the size, to make it lighter and faster. And the last problem, I think, is the gap between the server card and the embedded system, because the Linux system is divided to be server and embedded system. There are two worlds that they don't link very well. So that's another kind of challenges. So what's the openEuler's way to resolve? I think one word is okay, aggressive. So we will do some aggressive innovation or modification to resolve this kind of challenges. Okay, so I think Linux has been the most successful OS during the last several decades, and it can spread from the server cloud to the edge computing to the embedded system. It has been very successful in industry, but everything looks fine. But is it perfect? Is it so perfect? I think it's still a question for us. So first one is the chipset, challenge chipset. You know, OS always can work with the chipset. If you look back to the chipset development in maybe 5 or 10 years before, the chipset evolved very slowly. You just take care of Intel's chipset is enough. But more and more chipset has been appeared in recent years. So suppose you are a chipset vendor, what kind of situation you will face? It's very easy to understand. You tape out the chipset and you put the feature to the upstream kernel, and the upstream kernel, maybe it's not easy. Maybe spend half and 1 year to do that. And if the upstream kernel accepts the feature, and then the OS vendor will take the feature down and build the OS, and then this may also spend another half a year and push the OS to the customer, maybe spend another 1 year, maybe, to be mature. So it takes around 1.5 and 2 years. But a chipset, generally speaking, a chipset has 3-year life cycle. So that means half of the life cycle, chipset life cycle, will be spent to do this kind of job. The customer cannot access them. And consider the kernel evolve very quickly. 4, 5, 6, and 4.1, 4.2, 5.1, 5.2. And also the OS vendor also has a lot of kind of distribution. So they also exist a lot of OS vendors, right? So that is also a problem between the chipset vendor and the OS vendors. And in addition, we consider more and more chipset type. If everything is x86, it's fine. It's fine. It's not so complicated. But now, more and more ARM architecture has came into the market, especially for the server and the cloud. So more and more company will adopt the ARM server to use, right? And additional, a very shining star with 5 appears. And especially for in China, I guess there are maybe 50 company, kind of company, not big, small or medium company. They produce a lot of kind of refined chipset outside tape out. So when we consider all of those things, the OS and the chipset world is a big mess. It's very complicated. So how can we handle this in some degree? So openEuler will have adopted this kind of way. We will have the release. It's a normal way, right? We release a version 2 times per year. One is in the March, another in the September. So in this number, those release, we call the innovation release. You can put everything mature and blood bleeding features into those kind of release. You can make a trial. We provide some environment to do the verification job. And then per 2 year, we will release LTS, long-term service version, which can help the company. We will make sure the quality, and we will maintain the LTS for 6 years to ensure the company will adopt mature product. So that is the way. So our way is, if you want to try something new, to verify some chipset, you can go very early to the innovation version cycle, and you do the verification and go back to LTS version. And so we will adopt more aggressive release cycle to meet the aggressive chipset development. And secondly, for the new architecture, especially for the ARM and RISC-V, we will adopt very aggressive strategy to adopt these new features. So, a new feature, especially for some big feature, it's not easy or spend a very long time for the upstream, for example, kernel, glibc to accept the feature. But for openEuler, we open the door to those kind of feature to promote the usage of the new architecture. And then we have another very important feature is we share the same code base. In this point, we have released 2 LTS. For the second LTS, which is the 22.03, this is a very milestone version. In this version, no matter what the chipset you use, x86, ARM 645, they share the same code base. That means one code pool to create 3 kind of versions. So if you are a developer, you just keep to use the API. They share the same API. If you are a device producer, the driver will face the same kernel version. So we will maybe reduce the gap between the usage of the new architecture. Okay, so that's the general information how we handle the chipset issue, but it looks not so aggressive, right? As a regular way. Okay, let's move on. If we just consider the general CPU as consider, has been very complicated, but more complicated is coming because we have more and more GPU, DPU, TPU, or XPU, a lot of kind of PU. So for those kind of PU, how to handle them? And they evolve very, very quickly. For example, the DPU in China, I guess there are over 10 companies, startup company to do the DPU, very different SDK. And also, for a very complicated OS, every week we can receive over 40 CVE issues, vulnerable issues, how to handle them. And then OS release, you have to always update the kernel, update the OS in the cloud if you have millions of machines in the cloud. So they all need to make the kernel to be more flexible, cannot be fixed. So if you consider kernel is the interface between the hardware and the user space and the developer. It's a very traditional way for us to do that. But the problem is why we cannot handle the chipset involvement and so many new chipset type. The root cause is kernel is highly coupled and unchangeable. Unchangeable doesn't mean you cannot adjust it. You just can put some parameter into the kernel to do some adjustify, but it's very, very slight. It cannot change a lot of things. So generally speaking, when you change something in kernel, you have to compile it to be a new kernel and then deploy it again in cloud. So that means changing anything means to change everything. So that is the problem we have faced. So here we have a new idea. So is it possible to make those kind of key components of the kernel to be more modularized? So for example, we know nowadays the kernel will adopt the eBPF mechanism. eBPF is very good, but it's only used in the network in the beginning. Now expanded to more area, but most of the usage is still limited into the network. But it's a very good mechanism because you can make some policy in your space and compile it and inject into the kernel, and the kernel will run those kind of policy to do that. So it's a perfect design. That means the policy is divided from the framework. So framework is framework, policy is policy. Framework is only to load the policy to run it. So we can borrow those ideas. Is it possible if we can modify or redesign the kernel to follow this way? So that means the kernel only to run the framework, but we can make a different kind of policy in the user space and compile it and inject into the kernel to let kernel to always flexible. You can change something. Another way is in the left of the PPT slide, you can see the driver. In this system, especially for the kernel, we have a lot of kind of drivers. Driver is very complicated and not easy to migrate. But is it possible for us to make a new driver framework? That means you can write the driver once, but it can run in different kind of this kernel version. So that is also kind of an idea. If we can finish this two kind of step, that means we can handle some difficulties we are facing. So that is the framework we are doing. We call it a kernel as a service. We call it CAS. So the first photo step, I suppose we can release the first prototype by the end of this year. So welcome to came to openEuler to see it in this year. Okay, so the idea, you can see, our idea is to make the same kernel to be more lightweight and a streamlined kernel. But OS is not only kernel. They have a lot of things. For example, the virtual machine level and the container level, right? The kernel, virtualization, and the container, the three levels. The same idea, we think Docker is too big to sync. And also we think the Cumul is too big to sync. They get together and everything in the same image. So we developed two projects. One is for the Shuttlebird, which is to try to replace the Cumul system. And also we developed the Isla. Isla is also to replace the kernel, the Docker. So it's a very slight. It's only the maybe 10% the size of the Cumul or the Docker. For example, the Shuttlebird is only, I guess, 4 megabyte. It's very small and very fast. So it can be deployed from the cloud to the server, to the edge, even to the embedded. So embedded system also can enjoy the virtualization work and the container work. So that is the idea. And also, besides this kind of the structured component, key component of the OS, we also want to do some aggressive changes. We want to modify the number one process. Number one process we all know that is the system D, right? It's very big. So also we develop a new project which is called SysMaster. It uses Rust to rewrite process one to make it lighter and safer. Because if you get used to the QML or the systemd, you will find always have some CVE problem, always affected by the bugs. So we also for the server, we also use the Rust language to write the program. So we have we have done so many things, and also all of the project we want to make the things lighter and maybe faster. But it's only for this? No, we have bigger vision. So that means a universal OS platform. Because somebody will challenge that. Universal is a too big word, right? Okay, let's explain what it means universal, right? Actually, if you check our industry, you will find that there is a very clear line between the server side and the embedded side. For the kernel side, we often use the CentOS, SUSE, or Ubuntu. In the embedded system, you always use the WinRiver, Linux, or the Yocto system, right? But unfortunately, the two systems are totally unlinked. They share the different architecture. They share the different. They share nothing. They don't have the same code base. And if you use it, it's not totally different. And when you build a system, you want to do the CI/CD. The server side will use Koji or OBS, but for the embedded system, always use the Yocto. They're totally different. But everything should be connected. Not should. Is doing the connection around the devices and the devices to the edge computing and connect with the cloud. So everything of the system will connect together. So in theory, the ideal world is everything should share the same thing. And the application can run smoothly from the cloud to edge to embedded. And if I'm a chipset vendor, I just need to work with one group, and they can make it embedded, edge, and the cloud or server. They share the same thing. I don't need to work compliance with this vendor, that vendor, this OS or that OS. It's very tedious and consume a lot of effort and money. So is it possible to do that? Okay, so let's consider what is OS. No matter it's embedded or edge or server or cloud, actually OS is a collection of packages or components. So no matter you use as an embedded or a server, you share the kernel, right? Kernel is one of the packages, right? So we came up to an idea. So can we make the component to be component? And then if we want to do some OS, we can use some language or some config file. For example, the YAML file is very easy to understand, very easy to run, and just give the system a YAML file to describe what kind of OS I want. And then the compose system will produce the OS, what I want. So in China, we call it tenon and socket structure. It's a kind of structure used by the Chinese traditional building. It's the component is very similar, but you can use very similar component to form very huge building and also very small building. But internally, it's similar. So we build a system which is called OLA Maker, but of course it's still under the development. Also, in the middle of this year, we can release it maybe the alpha version, or call it a 1.0 version. It can reach the requirement that we have a very big component pool. You share the same code base, no matter it's x86 or ARM64 or RISC-V. They share the same. And then we provide a OLA maker composer system. And you can put some description or requirement for the OS to the OLA maker, and the OLA maker will produce this OS for you. So OLA or OLA openEuler is not a OS. It's not an OS. It's an OS platform which build different OS. So that is the, I think, a more accurate definition of openEuler. Okay, so let's do a small summarize. So we optimize the OS component for lighter and modular because we want those components can be deployed in cloud and to the devices. So we need to make every component to be smaller. And also we can use those components to reorganize to be different kind of OS. So that is to meet the different scenarios. So that is the idea. Okay, when we talk about it, we replace a lot of things, but it doesn't mean we abandon the old ones. So for the Docker, for the Cumul, it's still in our package pool. So you can use it to do this to compose the system. So we have just provide a second choice. Okay, I have told. But came to the end of the speech. More than that, we have developed a lot of new things. You can come to the website to see that. For example, Attune, AI-based performance tuning tool. You can do the performance tuning by AI. You use this kind of tool. You can have the kernel hot replacement, which can enhance the cloud ops technology, and we have Wei Xiong JDK, which is optimized for the ARM64 and the RISC-V. And also we have NFS Plus. We reorganized the protocol of NFS. NFS is very popular, right? But it's not fast, it's not robust, and not stable. So we redesigned the protocol to enhance and up to 6 times speed and more robust. And we have KeyMesh, Gazelle, and AI Ops. AI to use AI technology to do the DevOps. So until now, in openEuler, we have around over 300 kind of new projects. So if you can go to our website to find those kind of components, of course, you can use the component to other platforms, for example, Red Hat or Ubuntu. Okay, so here is I don't read the number right? It's very big. At least in China, it has to grow very, very big. Size, and we have accumulated a lot of developers, and we have accumulated a lot of organizations and companies. Okay, finally, so it's the end of the speech as a very quick introduction of openEuler. So here is the website. Of course, some of the material content is still written in Chinese, but if you find some this kind of issue, can report the issue to help us to improve the project. Here is the website, but after the website, you still have the project. We have Git repo. Over here, how to engage. So you can take the picture, and we can communicate in those channels. Okay, everything is new, so we try to bring some new things to the old OS industry. So welcome to join openEuler to enjoy the new world of the year. Okay, thank you.